Lesson 11-3, bivariate data. We've taken a look at univariate data already. Bivariate data is what we're going to go through today. So recall that univariate data are data in one variable. Bivariate, think of bi, are data that consists of pairs of values or two variables. Bivariate data can be displayed in different ways depending on whether the data are numerical or categorical. And each data display has strengths and weaknesses. So if you see in the example here, we do have two variables. We got students and then hours studied, and we got their test scores as well. So the two variables would be the students and the hours, or like the hours studied and their test score. These would be our two variables in there. So just like with univariate, we had some different displays. Bivariate, there's also going to be a couple other displays that we'll look at. One is a two-way table or a frequency table. Shows classified data in rows and columns. They're used to display categorical data. So here we have categories here, and we have categories up here. So we are comparing the type of candy, and then you're also comparing it between kids and adults. Some strengths and weaknesses. The strength would be it displays individual data points. It shows frequencies of data classified by two categories. You can compare the categories and subcategories. By the way, these would be the subcategories right here. But it can be difficult to visualize any trends. Next would be a segmented bar graph. Segmented bar graph is just a stacked bar graph where the sum of the segments in each bar is 100%. It is used to display categorical data. So both bars are going to be the same height. They must add to 100, must reach to 100. But if you notice, each bar has two different colors. And one's representing chocolate, one's fruity, and then you have your two different other categories down here, your subcategories, kids versus adults. So strengths, you show how a category is divided into subcategories. You can compare the categories. The graphs with many categories or subcategories can be difficult to read. So the more students you have, the more difficult it is to read. If you've got fewer you can have, the better. But 2 would be a good amount. 3 would be okay, but if you're doing 4 or more, then that can be a little bit harder on the same bar. Next is a scatter plot. Scatter plot is just a graph in the corner plane representing the data as a order as ordered pairs. It is used to display numerical data. Some strengths and weaknesses displays individual data points, but it can be difficult to see changes between data points. It's easy to visualize general trends. So in this example, you can see that there are more people attending the inaugural since further the trend has been going up. Next is a line graph that displays numerical data using connected line estimates used to display numerical data. Easy to see changes between data points as you can slope from one point to the next. It's useful to show how data change over time. So that's the key part with line graphs. You use change over time. Many display individual data points, and graphs for large data sets may be difficult to read. So if you have hundreds of points on one data on one point plane, and they're all stacked together, it can be difficult to read. So our first example, the two-way frequency table summarizes the membership data from the soccer team, the debate team, orchestra, and service club. It is segmented bar graph to show what percentage of members in each organization are in each class, and determine which organization has the largest percentage of seniors. So the first thing we need to do is we need to put these as percentages. So we're going to be going by what percentage of each team. So the soccer team, we need to know what the totals would that be. So let's look at here, we have a total of 20. So if I divide everything by 20, here, and then the debate team, divide all those by 20. And then orchestra by 50. And then the service club by 40. And you can see the totals on that side there. So 2 divided by 20 will give us 10%. So we could say 10% of the soccer team was freshmen. Sophomores was 20%. Juniors, 40%. Seniors, 30%. That would give us a total of 100% of the soccer team. And you can see a breakdown of each grade level for that team. For the debate team, we have 20% freshmen, we got 15% sophomores, 30% juniors, and 35% seniors. That would give us a total of 100% for the debate team. Orchestra, that's 30% freshmen, 18% sophomores, 30% juniors, and 22% seniors, which is also 100%. And then the service club, we got 30% freshmen, 25% sophomores, 22.5% juniors, and we have 22.5% seniors. That's also 100%. Now that we have it as percentages here, we can now create a segmented bar graph. So here we're going to create a key for each grade level. So I can use just a different color here. So maybe I use this purple for freshmen, sophomores. I will use yellow. I'll use blue for junior, and I would use green for senior. So then everything has to go to 100, and we'll do freshmen first. So freshman was 10%. So if I go 10% for soccer, and then let's do the debate team as well. 20% was freshmen. Orchestra was 30%. And service club was also 30%. So that was a freshman. Sophomores, we had 20% soccer team. So each box is 10%. 15% was sophomore for debate. So that's half of 1 and 1 whole, so that's 15%. We got 18% orchestra. So just under 2 full boxes. Then we have 25% service club, 25, so 2.5 boxes. Then we have juniors. Juniors would be 40% on the soccer team, so 4 boxes. Then we have 30% for the debate for juniors. So here's 5. $15, $20. There's 20, there's 25. We gotta get to 30. So we got, we're at 25, and 30 would be here. Next is 30% orchestra. So let's see, here's 2, 12, 22, and then 8 more, that would give us 28, or 30. Then we got 22.5% for service club. So this one, the previous one was 25. So here's 5, 15. We got 25. So this would be roughly here. And then we have seniors left over. Seniors was green. So seniors, we have 30% for soccer. Debate was 35. Orchestra, we had 22%. And we had 22.5% here. There would be our segmented bar graph. And if we wanted to put the percentages in each of the bars, you could do that, but you can see the breakdown. Now this one isn't too bad when you're dealing with 4 of them. So let's look at this one now. So you can see a little more specifically on this one here. Now we can determine which organization has the largest percentage of seniors. So the seniors are this green color right here, this lighter green. So we're going to find out which one has the biggest section. Here's the biggest section of seniors. That was debate. Next, the two-way frequency table summarizes two members' data for endurance, strength, balance, and flexibility. Create a segmented bar graph that shows gender percentages for each category of exercise. Then determine which exercise has the greatest percentage of males. So we have the totals here. And we're going to divide these by 20, these by 50, these by 20, these by 40, and these by 130. Actually, we don't have to do the totals part. So here, for endurance, we had 7 divided by 20. 7 divided by 20 is 35%. Male would be 13 divided by 20, 65%. Again, they have to add to 100%. Next, 5 divided by 50 would give us 10%. That means male was 90%. Balance, we had 17 divided by 20, which was 85%. Means 15% was male. Flexibility, 38 divided by 40 gives us 95% for female. That's 5% male. And if we did the totals, 67 divided by 130 gives us 51.5%. And 63 divided by 130 will give us 48.5%. That should add up to 100%. Now that we have those written down there, we can now go to step 2, which creates a segmented bar graph. Then we'll use 2 colors. We'll use red for female, and we'll use blue for male. We'll do the female first. So female endurance was 35%. 35% would be here. For strength, we had 10%. For balance, we had 85%. And flexibility, we had 95%. And then for males, we had 65% for endurance. We had 90% for strength. We we had 15% for balance, and we had 5% for flexibility. Then we can use this to answer our third question, which determines which exercise has the greatest percentage of males. The greatest percentage of males would be right here, 90%. That would be strength. Next part, the two-way frequency table summarizes political party data from the House of Representatives for 4 states during the recent year. Create a segmented bar graph to show what percentage of representatives in the 4 states are in each political party. Then determine which state has the largest percentage of Republican representatives. So we have California, Texas, New York, Florida are the ones that we are comparing. So this column for California divided by 52, Texas by 36, New York by 27, Florida by 27. And when we do that, for Democrats in California, that's 45 divided by 52 gives us 86.5. Republicans, that would be 7 divided by 52 gives us 13.5. Texas, we would have 13 divided by 36 gives us 36.1. This will give us, for Republican, 65.9. Or 63.9. New York, that would give us 21 divided by 27, 77.8. Republicans, that would give us 22.2. Florida would give us 13 divided by 27 is 48.1. And this would give us 51.9. Fill the rest of these in totals. We're not going to worry about the total here for a segmented bar graph. Okay, now again, I'm going to use blue for Democrats and red for Republican. So for California Democrats, we had 86.5. So 86.5 would be roughly here. Texas was 36.1. New York was 77.8. And Florida, we had 48.2. That means the rest would be red. Next question, determine which state has the largest percentage of Republican representations. So the lighter red is Republicans. So lighter red would be right here, which would mean Texas has the most Republican representatives in the House. Next, the table shows the total number of points scored in several NCAA men's basketball championship games create a data display and describe how the data are changing. So you can see the year from 2010 to the year 2019 and the total number of points scored in the championship game. So what we're going to do is first we're going to use our graphing calculator and enter the data in there. Since this is numbers, we know that we're finding change over time, which would be a line graph. So we need to enter all these data into our calculator. So again, you hit the stat button, hit edit. We're going to go to list 1 and list 2. And let's go back so we can see our data points. So if I hit stat, edit, we need to clear what we have up here. Now the other one, I'm going to keep as 0 because we wanted the first data point is going to tell us the time from 0, the years from 0, so from 2010. 2010 is 0 years from 2010. So I have to go 0, so we have 10 years here, so if I keep going down, okay, I got 10 years on here. Now I'm just going to enter the numbers in here, so 120. You got 94, 126, 158, 114, 131, 151, 136, 141, and 162. I think I skipped a number somewhere. So 120, 94, 126, 158, 114, 131, 151, 136, 141, 162. So I have to get rid of this number there. Then if we hit stat, actually we have to turn our stat plot on. So we go to second, y equals, mine is on, but if it's not, yours isn't on, hit enter, turn on. We want this point right here. Actually, we could go over to the line graph. That one, hit enter. Then if we hit zoom stat, which is number 9, you can see our line there. I have to get rid of something. I have clear this line so you don't see that. Go back to graph. Then there's our line. So if I go back to this slide, here you can see our graphs are very similar. Now we can answer some questions based on that. Describe how the data are changing from year to year. It says the line graph shows that the number of points scored have blank over time. Since it's not the same thing, we could say that it has varied over time. Between 2010 and 2019, the maximum number of points scored was 162. That's our highest point. Next, we'll just skip this question here. Here it says the table shows visitors' favorite activities at the country fair. Create a data display and compare the number of people who prefer each activity. Since we're just comparing the numbers, we'll just do a bar graph here. So hayride is 230. So 230 would be roughly here. Ferris wheel was 272. So almost halfway to 300. Games was 245. So almost 250. And And then the petting zoo was 201, so barely above the 200 mark. And there's our bar graph. In example 3, choose an appropriate data display. The data shows the number of students in each grade at a district's high schools. Determine an appropriate data display to compare the percentages of students in each class at each high school. So to do that, we need to convert everything to percentages here. But actually, no, we won't have to create one. It just says determine what would be the appropriate data display to compare the percentages of students. So to compare them, this would probably be best if we used a segmented bar graph because the data are bivariate. And it's bivariate because we have categories here and we have categories here. So two variables, high schools and the grades. And then it's categorical because we got subcategories here and we got subcategories here. To show how each category is divided into subcategories and compare the student populations using percentages, a segmented bar graph is an appropriate data display type. And our final question, the table shows the number of students in Mr. Kernohan's class who prefer different genres of music. Are the data bivariate or univariate? Are the data numeric or categorical? What type of display should be used to compare the number of students who prefer each genre? Explain your reasoning. So first off, is this univariate or bivariate? It's actually only univariate, and it's only univariate because we're only looking at music genre. Now, if they would have said music genre compared to genders, if you're breaking down the number of students based on gender, then it would be bivariate. But because it's just students and what they prefer, the music genre is your only variable. This is categorical because we have different categories of our variable that we are looking at. What type of display should be used to compare the number of students here? I would say the best one would probably be a bar graph. And the reason for a bar graph, it is categorical and the frequencies are small enough to display in a bar graph. Easy to compare categories. So that is our lesson on bivariate